And welcome, viewers, to the Daily Space Weather Show. I'm your host, Dan, a.k.a. Smash-O-Mash, coming at you from the Smash News Network, least busted name in news, just bringing you the world's most comprehensive daily space weather show and the most detailed solar imagery you'll find in the known universe. All three spots that we said to keep an eye on since yesterday have certainly been quite ionized and quite ionizing, as they've all three produced M-class solar flares. So the three brightest regions you'll see there, two on your left, one on your screen right, all produced M-class events. How's that for some forecasting? So first of all, this area down here in the southeast produced one of 5 M-class flares in the past 24 hours. And we're seeing an uptick in general in solar activity, all things considered. The radial flux, sunspot number, and incoming space weather. Now 2 coronal mass ejections on the way. We'll talk about it. We talked about one to arrive on the 17th. Here's that flare from the northwest. So now 2 coronal mass ejections headed in Earth's direction. Here's the largest flare producing region, this sunspot in the northeast. And right at the end of the video was the largest flare of the past 24 hours. So that makes that the T-mass, folks, the most active sunspot. And we'll get to more of that stuff here in a moment. How about an extreme close-up? That ain't bad. We'll take it. All right. So, and here's, just for sake of completeness, here is the 131 angstroms wavelength. That's dated from just today, the SDO Browse Data feature. As the sun ramps up in general. So as darkness falls over Iceland, we still do see activity there from that new cinder cone, although things are ramping down. So now the camera is zoomed much further out and showing only minor active lava flows there. Looking pretty still. If those are indeed flows, they are slow flows. Here's what else is erupting. Ibico. Producing a 15,000-foot plume of volcanic ash there. Similar ash plume altitude there over Ibu as it explodes. Luotobe also exploding. Luotolo exploding. Semeru. Discrete emissions from the East Javan volcano. Tucono. Fernandina continues to create new real estate on the Galapagos Islands. No, you can't buy it. It's some kind of a nature park for Ecuador. Santiaguito also producing an explosion and a 14,000-foot ash plume. Fuego. Nevado del Ruiz, 21,000-footer there. Also Sangay. Ravenador and Sabancaya, 23,000-foot plume of volcanic ash. Please do not pole vault the caldera, but please do visit the links below the video. Check out our merch shop if you haven't done so. You know, I think it's still the most popular piece of merch, the Do Not Pole Vault the Caldera. We like to put public service messages on the stuff. After all, we are patriots on the channel, I suppose. Not to be confused with the New England Patriots. So there are the past 90 days of earthquake activity. And let's take a look at what's been going on in the past 24 hours. Quite a few quakes there at Alaska. Shout out to our viewers from Anchorage. Let us know in the comments if you felt some quakes. There was a 5.4 at Papua New Guinea. And besides that, no 5 or greater magnitude quakes. And let's cover a little bit more solar imagery here. There's SDO 171 angstroms, the house favorite. Not too bad. It's a good time to be looking at high-res images of the closest star. There's the ionized helium of 304 angstroms. Oh, yeah. Oh, yeah. And by the way, we have named that huge arch-shaped solar filament. We'll talk more about naming solar plasma filaments a little bit later. They are lively things after all, so there's a whole purpose to it, almost like naming storms when it comes to weather stuff. Alrighty, so the 10.7 centimeter radial flux now up over 190 plus solar flux units as we approach new highs. No surprise there to people who are listening to sane forecasting regarding space weather. So yeah, sane forecasting there is expecting to see a rather average, possibly even still an above average solar sunspot cycle in terms of the radial flux, the thermosphere temperatures on Earth, also the sunspot number, the X-ray output, and people like Bob Lehman actually expecting the peak to come a little bit later than you may expect. We're expecting it to be in October, just basically by extrapolating the length of a solar cycle. Again, radial flux now at 190 plus. I think it's at 192, 191, something like that. That's a one-year chart from Solon.info. There you go. 192 is the radial flux. And like I said, 2 CMEs on the way now. In my opinion, one to arrive on the 17th and one on the 18th. So NOAA doesn't have the one for the 18th forecasted yet, but there's a forecast looking just like the one that we called out yesterday on the Daily Space Weather Show. Facts. And by the way, space weather ain't going away, especially with the emphasis on private space flight and using, of course, satellite-based internet and things of this nature. So yeah, space weather not going away anytime soon. It'll be increasingly important as time goes on, especially with people trying to put permanent bases on the moon and things like that. So yeah, it's kind of an interesting place to be, wouldn't you say? And yeah, congratulations on finding the channel, folks. Who knew we would be leveraged in such a weird place at such a weird time? But perhaps nothing's random in the universe, right? So anyway, ESA does have that second CME forecasted. And by the way, it looks like the one that we were expecting yesterday has shown up a little bit late. So even a little bit slower than ESA's forecast. We'll get to it, but first the last 4 hours of Earth's magnetic moment from space. So we are seeing a CME impact striking Earth right now. It's pretty tough to tell the velocity of a diffuse gas coming straight toward you, but there you can see the impact happening just in the past couple of hours. Here's Earth's magnetic moment from the ground, and we do have some minor chance of being able to see the aurora down at mid-latitudes. Expect to see significant aurora at high latitudes, though. So we should see some action in the places like the Twitter sphere. Again, make sure you follow us on Twitter. I don't think I've said it today. x.com/smashomash. So that's the past 4 hours of Earth's magnetic moment from the ground. KP index slightly elevated here at 2.33. We don't expect any geomagnetic storms at this point because this impact is looking weak. So here you can see a bit of a signal here on the ACE. Right there, that little uptick in solar wind velocity there, not even making it up to 400 kilometers per second. The density not even making it to 12 protons per cubic centimeter. Also, the magnetic fields are not the optimal magnetic fields to induce major geomagnetic storm conditions. So we'll call out the numbers for the Discover. Current solar wind velocity, only 361 kilometers per second. Solar wind density, just over 7 protons per cubic centimeter. It did get a little denser and faster there. And you can see right there, you can see the magnetic field changes, as well as the plasma temperature, the velocity, the density, and the phi angle shifted as well. Keep in mind, folks, the solar plasma does carry its own magnetic fields, and you know it's like a roving little magnetic field just flying through space, just a cloud of ionized gas. So yeah, anyway, that's the Discover. Minor CME impact happening here a little bit later than anybody expected. And I mean anybody, like NASA, NOAA, this channel. I don't know anybody that forecasted it as slow as it is. Again, it's very difficult to determine the velocity of some diffuse gas that's coming directly toward you with practically no contrast. That said, GOES magnetometers here. We had an arcjet moment there from the GOES 16. The GOES 16 had to maneuver to maintain its geosynchronous near equatorial orbit. That's probably the onset of the geomagnetic storm, or the minor CME impact. You know, it did induce a little bit of current there, so there would have been a little bit of puffiness in the ionosphere. Now keep in mind, well, that's really in the thermosphere, as it's at a very high altitude, like 23,000 miles of altitude is where the GOES 16 and the GOES 18 do their orbits. Let's talk heliosphere magnetism. South pole magnetism remains the order of the heliosphere, at least the part the Earth's in. You can expect that to stay the same for days here. It looks pretty stable. South pole magnetic sector of the heliosphere. Next is our line of sight field plot, showing a lot of info in a little time. That's 4 days worth. And we are seeing some changes happening there to the B field, which is the blue lines. See those blue lines undulating a bit? They are somewhat like a product of the polar fields. The B field, folks, is the field that goes through the magnet if this magnet is the sun. Polar fields depicted by red and green lines. Those are the potential field surface source lines of the polar fields, south for north, red for south and green for north. And the photosphere magnetism there, the layer of the sun where sunspots occur, shown there in grayscale. So that's a lot of information. That's the past 4 days of line of sight solar fields. Here's our line of sight coronal hole plot. And as forecast there, lots of south pole oriented coronal holes rocking their way around. And we've got a very boxy coronal hole right now. Let's get to it. Let's get to it. And first, let's pause for station identification. You've reached the Smash News Network least busted name in news. Zoom. So there's that boxy coronal hole there. It's got 4 corners. It's almost shaped like a trapezoid. And of course, everybody knows that in space and weather phenomenon, any kind of a shape is scary. So that could be a reason to get in your bunker, folks. We do expect that to become geomagnetically effective in like 4 days or so. So some reasons to get into the bunker: shapes, trapezoids, squares, rectangles, octagons, even rhombuses. Rhombuses are very scary. When seen in nature, your bunker should be locked up with you inside of it. And you may want to consider padding the walls of your bunker, depending on how long you're planning on locking yourself in there. These facts brought to you by the Smash News Network, least busted name in news. And let's talk sunspots, as we are right on schedule to what we were saying yesterday about sunspot numbers. And there you go. Sunspot number now over 160. Sunspot number to like 165, something like that, according to Rob, the Royal Observatory of Belgium. So here's our flare probability monitor and scoreboard, and we're seeing as many as 12 named groups there showing up in the flare probability. And what can you say? We still have the high likelihood of large solar flares, especially in the same regions that we called out yesterday. So those would be known as sunspot 3638, 3639, and 3634. Those are the 3 groups to really watch. And by the way, we'll have another modest uptick in sunspot number tomorrow. Sunspot number tomorrow will be reaching up toward 180. So it looks like some of those sunspots not yet counted, as we don't see names on some of those numbered groups there. So sunspot number expected to rise. We also see some growth right in the Earth-facing portion of the solar disk. Let's cut to that next, shall we? Oh, we shall. We shall indeed. We shall indeed. So, here are there you go. There's the SDO magnetogram data. And mostly stable there. No major changes happening. I thought I saw some growth. Let's switch to the continuum. And by the way, thanks for stargazing with the Smash News Network, least busted name in news. There's no more interesting star than the one that's the closest. And remember, folks, part of the reason why we make these videos is because of the implications of heliophysics on cosmology. Back in the mid-1990s, I realized there is a huge hole in our understanding of heliophysics. I almost majored in cosmology back then before I pursued pro sports. So, yeah, this looks like a minor uptick here as we see some growth in that north-central sunspot group, also in the southeast. Yeah, so there's growth still happening here. There will be new sunspots on the list, even though that one is setting in the west. We will have more new sunspots than we will have to offset that small setting group in the west. So facts, next solar energetic particles, and flares. So no spikes in the proton flux there or energetic particles. That's SEPs that goes proton flux there. That's the protons that are greater than or equal to 10, 50, and 100 million volts, meaning they got some juice. So, yeah, 5 M-class flares in the past 24 hours. 5 M-class flares, count them. Or don't. You can just believe me when I say 5. I've counted them for you. I know people are a little bit lazy in terms of their doing research in the year 2024. I don't know if that's because of the year 2020 and so on, but man, it's all in good fun, except when it isn't fun. So yeah, there are the past 24 hours at 30 frames per second, SDO 94 angstroms, one of the many species of ionized iron. 94 is great at showing active regions. It takes 10 images per minute, so it's got a higher temporal resolution than all the other wavelengths. Except for 131 angstroms, 94 angstroms is a good time. And while we're talking flares, here's an extreme close-up of the T-mass, the most active sunspot group, having produced the largest solar flare of the past 24 hours, sort of right in the last couple of seconds. There it goes. So that's a thing. How you like them apples? Facts. Still controversial in the year 2024. Can you believe it? You'd think facts would have started to, catch people's attention, but apparently facts, they're still a little bit too spooked to facts, folks. Ooh, look out for the spooky, spooky facts. They might refute your dogmatic attribution to nonsense. All right, so yeah, it's hey, happy tax day. Congratulations to everybody who got a tax return. Oh, well done. Well done. You've let the government borrow your money all year, and now you're like, dude, I got a tax return. I'm getting paid. That's your money. You should have had it in an escrow account bearing interest all year long, and you should pay taxes so you feel the sting and understand how much you pay. All right, now I'll stop Peter Schiff soapbox tax talk, financial wonk nerd stuff. Yeah, I used to be a day trader, folks, so I know a little bit something about economics. And I know that doesn't qualify you to understand economics, but anyway, here's a solar system forecast. And by the way, space weather absolutely affects economics. So here is our 1 week solar system forecast as Mercury decides to abandon Earth on this lonely side of the solar system. That's where things will be in a week. Venus speeding away as Earth catches up to Mars. And there is our star chart. If you're viewing the early evening sky, you should get a great view of the moon near your zenith. And if you're up before dawn, you might be able to get a load of Venus and Mercury. They'll both be rising ahead of the sun there tomorrow morning. But catch them. Catch them fast because they're fast movers. And let's talk about our astronomy photo of the day. So this is visible imagery on the left from Hubble and infrared imagery on the right from the James Webb Space Telescope. So seeing these structures in the center of M82 is super interesting. And basically what you have there is you have a galactic superwind that is created by not the core of the galaxy, but the net output of a bunch of stellar jets. So galactic cores have a tendency to have really hot, massive stars that are very active orbiting them in all kinds of funky orbits. What's interesting about this is that so many of those galactic jets are perpendicular to the galactic plane. That is why you have these galactic-scale jets. It is evident in that James Webb image. Now keep in mind that's mostly going to be oxygen, the blue part, and then the red part is going to be hydrogen. And then those dark areas, those absorption features that you see, those are going to be heavier elements that are basically blocking the view of the material behind them. So heavier, dusty plasma material, highly ionized. It's near the galactic core. So that's the core of galaxy M82. And let me just reiterate what I've stated here. Yes, it probably has some kind of a supermassive object at its core, a massive radio source that has massive jets. They're probably somewhat perpendicular to the galactic plane, the ecliptic plane of the galaxy. However, the net jets are created by individual stars. Look at that pane over there to the right. You can see that there's not like one clear source for all of those jets. It just so happens that those stars, they have their polar fields aligned in such a way that their jets are oriented largely perpendicular to the galactic plane, period. Like, this is a common thing. We see lots of structures in the universe that are at 90-degree angles to each other. I mean, the polar fields versus the equatorial plane of a star, anyway, I won't get into it. It is the daily space weather after all. apod.nasa.gov if you want to read about that. And if you enjoy the content, don't forget to press the like button. We work kind of hard to continue creating these videos, and we would prefer for the channel to continue to exist, remain publicly visible, and free for all to view. So yeah, we'll be lucky if this channel makes it in the current format to this solar maximum, which we're expecting in only 6 months. So yeah, press the like button. If you're new to the channel, press subscribe and visit the links. There are all kinds of ways to support the channel and increase the likelihood it will continue to exist. After all, it is the least busted name in news. Moving on to CMEs. And there's another one on the way. You may see a halo-like feature on that imagery right there. See that halo-like feature? And there it goes. There it goes. There it goes. Anyway, there's another CME headed this way. It'll be another minor impact. Won't cause a major geomagnetic storm. Probably not more than a KP6 at the most. Probably more like a KP4 to 5. So minor geomagnetic storm possible. More likely something just like geomagnetic unrest, if anything. But expect somewhat of an impact there, and we'll show you the filament that ejected. So here we've just kind of included some more data here for you, and once again, it's pretty stealthy, so this is one of the many reasons why we use difference imagery so often. It helps to create some contrast. Let's just move on to stereo A. And we do see some impacts happening here. These are likely relativistic particles striking the stereo A coronagraph. And let me bring these back and play them through. So we'll just include today mostly. So once again, a somewhat stealthy coronal mass ejection there. Expect arrival on the 18th. What can I say? And before we get the filaments, we've got to show the location where the Space Weather Station made a determination that what in tarnation? So yeah, a filament blasted off. It was somewhere around this area. Somewhere in this area here. It's actually pretty hard to see here. But when you start following these things, you start to get a feel for it. So that's what happens when you immerse yourself in the data, folks. Immersing yourself in the data. It makes a huge difference. And by the way, these videos come from helioviewer.org. If you're wondering, helioviewer.org. Just a spectacular website. And let's go to filaments. So yeah, filaments, that's what we're talking about. And you're going to see one blast off. You're going to see one which is there, and then it's gone. I guess that's a better way to put it. And it's kind of just to the west of this huge arch-shaped filament. So it'll look better in this view. So let's go back to full screen. What has happened? There we go. I guess I can stay on screen. So this filament right here is now on the way to right there, wherever you are, even if you're orbiting the Earth. So that's another Earth-directed CME there. Again, it'll be a minor impact. And before we get the bonus features, here are the past couple of hours from the GOES 16. Solar flare watch remains in effect, folks. We could see an X-class event. We could see multiple X-class events. And the likelihood of coronal mass ejections going into tomorrow remains at nearly 100%. Let's talk about naming filaments as well. Like I said, we named that filament after one of our viewers. Shout out to Wout Arty Noobs. And again, if you want to name filaments after living people, do it over on Twitter. x.com/Smashomash. Join us over there. This is not some kind of a bait and switch to fill your heads with political nonsense or anything like that. However, there's a great auroral network over there, and a great making fun of people who believe in chemtrails network over there. So, yeah, it's there's all kinds of interesting interactions that happen over there, making some new fascinating friends, and of course, we like taking photographs of clouds and saying, "Oh no, they're spraying again. Quick, lock yourself in the bunker, folks." Anyway, follow the hashtag Name That Filament. Name them after your friends, your foes, or even yourself. Charging hazards are the first bonus feature. And we've got some minor ones over the Northern Indian Ocean and the Middle East. The GOES electron flux here is seeing some recent perturbations. That's not too much of a surprise with the onset of a minor coronal mass ejection impact. So that's somewhat expected. You can see the coronal mass ejection impact there reflected in the GOES electron flux data. Here's the past year from Solon.info of electron flux, the relativistic electrons. And here's a forecast model from NOAA. NOAA's expecting an ongoing dip, and I would tend to agree, especially on the 17th and 18th when 2 CMEs are expected to arrive. We'll show the layer where it's measured as well, the F layer where it's measured, from well up above it. The F layer is at about 300 kilometers. The GOES 16 and GOES 18 are at like 23,500 miles of altitude. So there is the F layer. Again, that's at about 300 kilometers of altitude. The ionosonde depicts megahertz, millions of vibrations per second. It's very diffuse gas there at the bridge between Earth and space. And if that's all Greek to you, don't worry. We've got the anomalogram. Anomaly in megahertz from a 30-day median. So very average looking there. Very average. I mean, you get a great view of the South Atlantic anomaly, the equatorial African anomaly there on the west coast of Africa. There is another smaller anomaly there in Southeast Asia. You could call it the Korean anomaly. But, you know, that's a very average looking ionosphere. Very average indeed. And just in case we're having any funky stuff going on, here's the total electron content on the left and the maximum usable frequency on the right for you GPS and radio operators. So the total electron content depicts high electron counts in red, low electron counts in blue. And those high electron counts can cause some massive GPS errors. It's a great, pretty high resolution map, and I endorse that. That is good times. We've demonstrated GPS errors by doing bike rides with average speeds of over 10,000 miles per hour. Yeah, that's a reason to turn off Wi-Fi location accuracy to get an average speed of 10,500 miles per hour. And my helmet didn't even melt. Isn't that amazing? Anyway, here are the latest magnetogram and intensitygram. And again, we're expecting another uptick in sunspot number, a modest one. Probably see sunspot number hit like 180. Radio flux might not even go up again, as it's already at. See, the radio flux doesn't require anybody to count anything. So that's a very different measure than sunspot number. And let's move on to meteorology. So we're looking at the world's lowest pressures right now, and it's autumn in the Southern Ocean. And man, it's a roiling mess down there. It is not a good place to go sailing. It's a good way to get deep sixed by sailing around the Southern Ocean right now. It's very stormy. The pressure there was 949 hectopascals. So that is not an optimal place to be going on a boat ride. All right, so here are the surface winds of the east. Shout out to our viewers from the east. Jet streams, central world, surface winds, western world, and the jet streams. Satellite imagery's next. How sweet it is that we have access to such awesome bits of data. So good. And look at that massive low there showing up at the Azores. Yeah, the Azores. That's on my bucket list. What about you? Check out the temperatures in southern Texas. 104 degrees there near the southern Texas-Mexico border. Dag! Folks, the sun is shutting down, and that's why it's 104 degrees in Texas. I think some grand solar minimum cult priest told me that. Is that? Let us know in the comments what you think. Watch out, folks. There's 165 sunspots right now. The sun's shutting down. Make sure you follow Bob Lehman and Scott McIntosh. That's Leamon and Mcintosh. Bob Lehman and Scott McIntosh. Guys who make rational forecasts about solar activity. Pretty cold in Greenland, but not in Texas. Not in Texas. Here's our weather.gov map. And we got some ridiculous weather warnings there from NOAA. We'll scroll down to show you the key. Check it out. I like this one. Brisk wind advisory. Ooh, there's a brisk wind that requires the National Weather Service. Oh, noes. A brisk wind. Ooh. Oh, a brisk wind. I'm spooked of a brisk wind. I need warnings about that while I stroll through a dewy meadow. Oh, not a brisk wind. Oh, noes. I'll have to stay off the bike if there's a brisk wind. So here's the 72-hour GFS pressure and precipitation forecast from Tropical Tidbits. Yes, as this low makes its way up toward the Great Lakes and then eastern Canada. It'll be dropping some rain on us in the mid-Atlantic states. And you should have kept it. Who ordered that rain? Let's get some weather mods to the north of that to suck that farther to the north and keep it in Canada. Next is our accumulated positive snow depth change in inches, and Wyoming's going to have some 2-foot snowstorms there. 72-hour GFS accumulated positive snow depth change in inches. Also, we've got total accumulated precipitation in inches. Some heavy rains coming to Iowa, Kansas, Nebraska, South Dakota, and Minnesota. Actually, Nebraska and South Dakota, Minnesota, and Iowa especially. Gonna see some 3-inch rains there over the next 3 days. And then a second storm moving in there at the end. Looks like a fast mover. Not to be confused with a fighter jet. Last but not least, we've got the temperature anomaly forecast in degrees Celsius. Southern half of the country to remain anomalously warm. Northern portion of the country, a little bit anomalously cold, especially places like Montana, otherwise known as Montana. I want to go to Montana just to call it Montana. Montana. Anyway, lightning's next, and South America's got its share. Autumn lightning. And here's a real-time lightning map, and we've got a number of strikes in the past couple of hours in the U.S. Sup with that. Sup with that. West Virginia. Hey, it's the Seneca State Forest. There's some thunder rolling in. According to blitzortung.org. We'll close out with Doppler radar, visible satellite, and water vapor. So there's the lower 48 view. And here is the satellite view. And here is the water vapor view. That's what you use when your Doppler is unclear, folks. The water vapor map. So you see that huge demarcation line there stretching up that line of dry massive air. You can see the way it's constraining that moisture, forcing it to follow the jet stream path there to the east. Just a fine example there of basically a wall of air separating those two systems of moisture. A prime example of how it's very obvious that dry air is more massive than moist air, because atmospheric nitrogen is simply heavier than water vapor. So yes, a cloudy sky is less massive than a clear sky. I know it seems counterintuitive. These are facts. Doppler radar, visible satellite, water vapor is where we'll close things out. And so 2 CMEs on the way. Thanks for tuning in. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back while I go back to the bunker, because I'm spooked of space, pardon the sarcasm. Whoa.